How are you, my friends? This is Calculus 1 Solved Questions. In this video, we will use related rates in these word problems. And this is part 1. So as usual, you can expect part 2 and maybe more. Here we have to read the question carefully 1 or 2 times sometimes. Question number 1. At what rate is the area of an equilateral triangle increasing if its base is 10 centimeters and is increasing, the base is increasing at the rate of 0.5 centimeter per second? Now, if we draw a sketch for question number 1, we have equilateral triangle. All the sides are equal, x, 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 and there is the height here. When you draw the height, this will be perpendicular 90 degrees to the base. You can draw the height here also, then this will be the base, which is the same. So I have drawn this height here. H is the height. See, the height is h, perpendicular to the base. Now we have given dx over dt. The base is increasing at the rate of 0.5 centimeters per second. Now we know the area of a triangle in general will be half the base times the height. So if this is the base x, the height here h is square root of 3 x over 2. We know that in the equilateral triangle. If you don't know it, I put it here for you. Right triangle on the right. See, take this one here, use Pythagorean theorem. X squared is equal h squared. Half of this, it will be h over x over 2 squared. Square this, take it on the other side, subtract, you get h squared, 3x squared over 4. Take the square root of both sides, so h will be square root of 3x over 2. Then multiply by x, which is the base, multiply by half from the formula. So you will get the area, square root of 3x squared divided by 4. This is the area. Let's use the chain rule. The derivative dA over dt will be dA over dx, the derivative of the area with respect to x, times dx over dt, which is given 0.5. So let's differentiate here. Differentiate 2x will be the derivative from x squared. So square root of 3, 2x divided by 4, multiply by 0.5. Now at x equals 10, that's given also. At x equals 10, we have to find the rate of change of the area dA over dt. If you put x here 10, it will be 5 square root of 3 divided by 2 centimeter squared per second. Question number 2 is sand is being emptied from a truck at the rate of 10 feet cubed per second. The sand forms a conical shape whose height is always twice the radius. You know, there is a cone here. I will show it to you now. At what rate is the radius of the cone increasing when the height is 5 feet? So here we need the rate of change of the radius of the cone when the height is 5 feet. So let's make a sketch here. This is a cone. It's given the height is 2 times the r. This is the radius here for the base, and this is the height. Now the volume is 1 over 3 pi r squared h. It's given here. dV over dt, this is the rate of change of the volume, 10 feet cubed per second. Okay. So now in the volume we have r, we have h. There are 2 variables, so we have to make it 1 variable. So we use this from the given. The height always is 2 times the radius. So instead of this h, I put 2r. So it will be 2 over 3 pi r cubed. Now this is the volume, the function of r. Let's use the chain rule. dV over dt will be dV over dr times dr over dt. Now dr over dt this is what we need. So I can replace here dV over dt is 10, 2 over 3 pi The derivative here, remember, 3r squared. So this is 3r squared. dr over dt, this is what I need. So when h is 5, see h is 5, then r will be 5 over 2 because every h will be 2r. So r will be 5 over 2 here, 25 over 4. Okay, just simplify all these numbers here. Divide by 2 here, this and there, divide by 3, 25 pi, and then divide by 5 again. So dr over dt will be 4 over 5 pi feet per second, which is almost 0.25. Question number 3 is really nice. A gas balloon is being filled at the rate of 100 pi centimeter cubed of gas per second. So we are filling a balloon. At what rate is the radius increasing when the radius is 10 centimeters? Now, this is a sphere. Balloon is a sphere. So you can use this one here, volume of a sphere, 4 over 3 pi r cubed. This is a balloon here. So it's like a sphere. So the volume will be 4 over 3 pi r cubed. Now, given dV over dt, the volume is increasing at the rate of 100 pi centimeter cube per second. We need dr over dt. Just differentiate. See, this is one variable here. The volume has one variable, only r. So dV over dt will be dV over dr times dr over dt. This is given 100 pi. This one we differentiate, 4 over 3, leave it. Bring 3 down, 3 pi r squared times dr over dt, which we need. At r equals 10 centimeters, so I can put here 10 squared, that's 100, and this 100 from the question. 3 is cancelled, 4 pi is there, so dr over dt will be 1 over 4 centimeter per second. For more questions on related rates, you can see lecture number 13 of Calculus 1. And for more questions on Calculus 1 in general, you can see Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.